Hi everyone, and welcome back to the channel. Today, we're diving into a topic that is not just important, but urgent. It's about how engineering can literally shape the future of our planet through the lens of sustainable development. Now you might be wondering, what does engineering have to do with sustainability? The answer is everything. Engineers design the systems we live in, from buildings to roads, from water supply systems to renewable energy grids. Every decision an engineer makes has consequences on the environment, the economy, and society. So today, we're going to explore a presentation I've made on sustainable development, engineering our future. I'll walk you through the main ideas, show how they apply in the real world, and explain why this is a topic that every aspiring engineer, policymaker, and citizen should understand. Let's start by understanding what sustainable development actually means. Sustainable development is about meeting our needs today without compromising the ability of future generations to meet theirs. But what does that mean in practice? It means we have to strike a delicate balance between three pillars: environmental protection, economic growth, social equity. If we only focus on one or two of these areas, we end up with unsustainable systems. For example, rapid industrial growth without environmental care leads to pollution and climate change. On the other hand, overly strict environmental regulations without economic consideration can hurt jobs and communities. That's where engineers come in. They're trained to solve problems with efficiency and creativity. If we embed sustainability into engineering decisions, we create systems that can support generations to come. Now let's talk specifically about why this matters in engineering. The first reason is to minimize environmental impact. Think of the massive carbon footprint from traditional construction or manufacturing industries. Engineers can switch materials, optimize designs, and reduce emissions dramatically. Second, it's about promoting social justice. Engineers can build systems that ensure clean water reaches every village, or that renewable energy is available even in rural areas. Equity is key. Third, we need to ensure economic viability. Projects that are energy efficient, durable, and maintainable offer better long-term value and reduce waste. And lastly, there's an ethical responsibility. Engineers don't just solve technical problems. They must consider their social and environmental responsibilities. Designing a dam isn't just about physics. It's also about the people who live downstream. So engineering today isn't just about function. It's about responsibility. Now let's zoom in on what exactly engineers can do. First, they can design eco-friendly infrastructure. Think green buildings, roads that use recycled materials, or bridges that last longer using less concrete. They can integrate renewable energy into systems: solar, wind, hydro, even geothermal. Waste is a huge issue. Engineers can work on waste reduction technologies, like converting waste to energy or improving recycling systems. And they can also design climate-resilient infrastructure, like flood-proof cities or buildings that stay cool without using excessive electricity. A great example is the Masdar city in the UAE, a project designed to be one of the most sustainable urban communities in the world. Or in India, engineers are creating low-cost water filtration systems, using natural materials to provide clean drinking water to remote villages. These aren't just ideas, they're happening right now. In 2015, the United Nations launched the Sustainable Development Goals, or SDG'S. These 17 goals are a universal blueprint for ending poverty, protecting the planet, and ensuring peace and prosperity by 2030. What's interesting is how engineering is central to achieving many of them.
From building hospitals and clean water systems to creating efficient transportation and renewable energy grids, engineering underpins the infrastructure of every SDG. But here's the catch: achieving these goals isn't just about technology. It requires collaboration, innovation, and a deep understanding of local contexts. Engineers must work with policymakers activities most directly linked to engineering. SDG 6, Clean Water and Sanitation engineers design filtration, irrigation, and sewage systems. India's Swachh Bharat campaign is one such example. SDG 7, Affordable and Clean Energy. Germany has made major strides with solar power. Engineers help design vast solar farms and energy storage systems. SDG 9, Industry, Innovation, and Infrastructure. SpaceX's Starlink project is a perfect example. Global satellite internet coverage for better connectivity. SDG 11, Sustainable Cities and Communities. Look at Singapore's Smart Nation initiative. Data-driven infrastructure planning, efficient transport, and green spaces, all engineered. The impact here is not theoretical, it's transformative. In 2015, the world signed the Paris Agreement, a commitment to limit global warming to below 1.5 degrees Celsius. To meet that target, we need to cut emissions drastically. And again, engineers are essential here. They're designing low-carbon systems, solar grids instead of coal plants, electric vehicles instead of petrol cars, green buildings with zero net emissions. They're also enabling global cooperation. Through open-source technologies and tech transfer agreements, engineers from different countries collaborate to scale sustainable solutions. That's global problem-solving at its best. Now let's get into some key ideas that guide sustainable engineering. Systems thinking is the idea that nothing exists in isolation. A dam doesn't just hold water, it affects agriculture, ecosystems, and even politics. Life cycle thinking means evaluating the impact of a product from raw material to disposal. It's not enough to say a product is recyclable if it takes more energy to recycle than it's worth. Then we have factor 4 and factor 10. These refer to increasing efficiency by 4 or even 10 times. Imagine using 75% less energy or materials while achieving the same performance. That's powerful. These frameworks help engineers make smarter, longer-term decisions. A major movement gaining traction is the circular economy. Recycled concrete in construction not only reduces waste but also cuts down CO2 emissions from cement production. Modular electronics allow you to replace a faulty camera on your phone without tossing the whole device. Vertical farming allows food production in urban spaces using 90% less water than traditional farming. And the mantra, reduce, reuse, recycle, is evolving to include repair and rethink. Instead of taking make dispose, we move toward a regenerative loop, and engineers are the architects of that loop. So what's the takeaway? Engineers must apply their technical skills in creative, sustainable ways. They must recognize their ethical duty to society and the environment. Their work must align with global goals like the SDGs. And most importantly, they are building not just systems, but the future itself. If you're studying engineering or already in the field, remember, you're more than a builder. You're a change maker. And the future depends on your decisions. Let's build a world that works, not just for us, but for everyone, and for generations to come. Thanks so much for watching. If this video helped you understand sustainability in engineering, make sure to like, share, and subscribe.